Alright, welcome to another pre-AMC SaMi video. I'm Olivia, as always, and let's get started. So a mixture of 30 liters of paint is 25% red tint, 30% yellow tint, and 45% water. Okay, 5 liters of yellow tint are added to the original mixture. What is the percent of yellow tint in the new mixture? Alright, so at first we had 30 liters, and we had 25% red, 30% yellow, and 45% water. Right, these are all percentages. Okay, so how much of that was everything though? So we've got 30 liters, so 1% of that we would find times 0.01, we want 1%, that would be 3, and then obviously 0, 0, so that would be 0.3. So 0.3, that's 1%. So if we wanted to find what percent was the red tint, we can multiply that by 25, right? Or 30% yellow, we could multiply that by 30. But we know that 5% or 5 liters of yellow tint are added to the original mixture. So now we have 35 liters, and 5 of those liters are yellow. So 5 out of 35 now is yellow. 5 over 35, that's 1 over 7. 1/7 of it is yellow. Okay, and before we had 30% yellow. So remember 30%, we had our 1%, which is 0.3, times 30, that's 9 liters of yellow, plus 5, our 5 new liters of yellow. We've got 14 out of 35 is yellow. 14 over 35, that's the same as 2 over 5. 2/5, that's 60% yellow, or 40% yellow. 2/5 is 40%. All right, we've got the product of two 99-digit numbers. It has a thousands digit A and units digit B. We want the sum of A and B. Well, if we're only worried about the thousands digit and the units digit, we only need to look at the first 4 digits, right? The first 4 digit gives us the units to the thousands. So we've got 303 and 505. And that'll give us our ones place and our thousands place. So let's solve. 3 times 5, 15. Another 15. So already we have our units digit of 5. So units digit, that's B. B is 5. Continuing on, we've got another couple 15s. Okay, adding that up, we get 5, 1, 0, 3, 5, 1. So what's our thousands digit? That's our 3, right? The 4th digit is the thousands digit. So A equals 3. We want the sum of A and B. Remember, sum, think addition. A plus B, 5 plus 3, that is 8. Answer choice D. We want to pick 2 consecutive positive integers whose sum is less than 100, and then square both of them and find the difference of the squares. Which of the following could be the difference? Alright, consecutive integers, sum is less than 100, and we want to square both. Okay, so let's find 2 positive integers. Let's call them n, and then n plus 1. Right, they're consecutive, so one comes right after the other. N and then n plus 1. Then we want to square both of them. So squaring n, we get n squared. Squaring n plus 1, that's n plus 1 times n plus 1. We get n squared plus 2n plus 1. So n squared, then n squared plus 2n plus 1. And then we want to find the difference of that. So we want to subtract them. So n squared plus 2n plus 1 minus n squared. Now we have 2n plus 1. Okay? Which of the following could be the difference? Well, right away, we've got 2 times a number plus 1. And remember, when you multiply something by 2, it'll be even. Right? So 2n, that'll be even. Adding 1 will be an odd number. So we're looking for an odd number. Right? So let's find an odd number. Can't be 2, can't be 64, can't be 96. Okay. So now it's between 79 and 131. All right. So what are our two biggest numbers that we could use? Two consecutive positive integers whose sum is less than 100. So we need two numbers in a row, and then when you add them up, they add up to less than 100. So our biggest ones in that case are 49 and 50, right? 49 plus 50 is 99. That's less than 100. Okay, after that, we can find their squares, right? 49 times 49. 49 times 49, that's 2401. 50 times 50, that's 2,500. So the difference between those two, 2,500 minus 2,401, that equals 99. That's their difference of those squares is 99. So we see that's the biggest possible difference, right? Because they're from the biggest possible numbers. So our biggest difference could be 99. So E is out, right? 131, that's bigger than 99, so it's not a possible difference. That leaves our answer C, 79, as the only option. Okay, before district, the Unicorns won 45% of their games. During, they won 6 more games and lost 2. To finish the season, having won half their games, how many games did the Unicorns play in all? Okay. So, they won 45%. Then they won 6 more games, plus 6 more games, and lost 2. And now they've won 50%. Now they've won half. Okay, so how many games did the Unicorns play in all? Okay, well, 50%, that 50% that they won, that's going to be the 45% of games that they won, plus the 6 games they won, over their total games, plus the 6 they won, plus the 2 they didn't win. Right? So, 50%, that's going to be 45% plus 6 over games in over 100% plus 8. Okay, 2 cards are dealt from a deck of 4 red cards labeled A, B, C, D, and 4 green cards labeled A, B, C, D. A winning pair is 2 of the same color or 2 of the same letter. What is the probability of drawing a winning pair? Okay, let's label this out. So we've got red A, B, C, D, and then green A, B, C, D, which I've also written in red. So I'll just write green. Okay, so you win if you get either 2 of the same letter or 2 of the same color. Okay, so let's pick our first card at random and then figure out the probability of winning from there. So let's say our first card is our red D. Okay, what else is going to make you win? Well, you could draw any of the other red cards, right? A, B, or C. That would make you win, right? Because 2 reds make you win. Or you could draw the other D, right? Our green one. So when you draw this red card, the 3 other red cards will make you win, plus the other cards with the same letter. So that's 4 winning cards after you draw the first out of 7 left over, right? After you draw this D, there's only 7 cards left. So there's 4 winning ones out of 7 total. Answer choice D. Lemming sits at a corner of a square with side length 10 meters. Let's draw that out. All right, we've got our square. 6.2 meters along the diagonal. And then stops, makes a 90-degree right turn, runs 2 more meters. So now our lemming's here. And we want to know the distance between each side of the square. Okay, well, we know the side of the square is 10 meters long, right? So either way, no matter where our lemming is, its distance from one side plus its distance from the opposite side is going to add up to 10 meters, right? Because essentially we're just drawing a line across the whole square and then splitting it at a point. So it's going to be 10 meters from adding up the distance from the left side plus the difference from the right side, right? 10 meters away in total. Okay, and then you can do the same with the top and the bottom. So it's 10 meters away from not the top or the bottom, but in total from the top and the bottom, right? Because this distance here plus this distance here is going to give 10 meters. So it's a total of 20 meters away in total from all of them. What's the average of these four distances? Well, we've got 20 total, divided by 4 is 5. Answer choice C. Okay, now we want to know the area of the shaded pinwheel shown in the 5x5 grid. Okay? Well, let's look at part of it at a time. Okay, so we've got a 5x5 grid, so the total area of this is 5 times 5, that's 25. Okay, and now to find the area of the part that's shaded in, we could take away the part of the area that's not shaded in, and then we're left with just what's shaded, right? So what's the area of the not shaded in part? We've got a square here, area is 1 by 1, so this has area 1, another one with area 1, and then 2 more. Okay, so now we've counted for these 4 chunks. Nice. Okay, what about this triangle? We see that the triangle has a side length of 3, and then this middle part, it goes to the middle of the 5x5 grid, so it's going to take up half of that, right, because it's going to the middle, so it's taking half the distance of the whole thing. So it's going to be 5 divided by 2, 2.5 is that distance. Right, so now we've got a triangle with base 3, got a height of 2.5. What's the area of that triangle? 3 times 2.5 divided by 2, right? Base times height divided by 2. That is 7.5 over 2. And there's 4 of them, right? We've got 4 of those triangles. So we'll do 4 times 7.5 over 2. We can cross these out. We get 2 times 7.5. That is 13. Right? That area is 13. So if our unshaded region, all of this, and all of this, and all of this, and all of this, and our corners, they all add up to 13, and the total square is 25, doing the 25 minus the 13 is going to leave us with just the shaded in area. 25 minus 13, that is 12, which is answer choice E. A bag contains 4 pieces of paper, each labeled with one of the digits 1, 2, 3, or 4, no repeats. 3 pieces are drawn to construct a 3-digit number. What is the probability that the 3-digit number is a multiple of 3? Okay, so let's review a fact about multiples of 3. So that is, if the digits of the number that you're looking at add up to a multiple of 3, then your number is a multiple of 3. So what do I mean by that? Like, let's say we have the number 27. I can add the digits 2 plus 7, that's 9, and I know that 9 is a multiple of 3, right? 9 is 3 times 3, so 27 is also a multiple of 3. We can see another example of that. 45. 4 plus 5 is 9. 9 is a multiple of 3, so 45 is a multiple of 3. Okay, so now we can look at 1, 2, 3, or 4. So we could either draw 1, 2, and 3, 2, 3, and 4, 1, 2, and 4, or 1, 3, and 4, right? So in this case, we have no 4, no 1, no 3, no 2. So no matter what order these digits in for all of these cases, like whether we have 1, 2, 3, or 2, 1, 3, they're going to add up to the same thing, right? 1 plus 2 plus 3 is 6. 2 plus 1 plus 3 is 6. We're using the same numbers, so they're going to have the same addition. And because 1, 2, and 3 add up to 6, 6 is a multiple of 3, any combination of 1, 2, 3 will be a multiple of 3. So that case always works, where we have 1, 2, and 3 in some order. What about 2, 3, and 4? 2 plus 3 is 5. 5 plus 4 is 9. 9 is also a multiple of 3. So any combination of 2, 3, and 4 works, right? Whether that's 3, 4, 2, 3, 2, 4, it's going to add up to 9 either way. Okay, now we have 1, 2, 4. 1 plus 2 is 3, plus 4 is 7. 7 is not a multiple of 3, right? That case doesn't work. And lastly, we have 1, 3, and 4. 1 plus 3 is 4. 4 plus 4 is 8. 8 is not a multiple of 3 either. So when we have 1, 3, and 4, we won't get a multiple of 3. So out of our 4 cases, right, where we leave out 4, we leave out 1, we leave out 3, or we leave out 2, the only ones that work are these two, are 2 out of the 4 cases. That'll have a multiple of 3. So 2 over 4, that's the same as 1 over 2, which is answer choice C. And remember what we did here, we found out multiples of 3, you can add up the digits, right? If that's a multiple of 3, then your number's a multiple of 3, right? That's the important thing to remember from this. Okay, we've got a dartboard. The outer circle has radius 6, right? So this line, big R, we'll say that's the big radius is 6, and the inner circle has radius 3. So little r, the smaller radius, has radius 3. They divide each circle into 3 congruent regions with point values shown. What's the probability that a dart will hit a given region is proportional to the area of the region. So when 2 darts hit this board, the score is the sum of the point values in the region. So what's the probability that the score is odd? So the probability that the score is odd, how would we get an odd? So there's 3 ways we could do this. We could either get a 1 and a 1, a 1 and a 2 and a 1, or a 2 and a 2. Right? So let's look into all of these cases. If we had a 1 and a 1, the score would be 2, so that's even. If we had a 1 and a 2, the score is 3, so that's odd. 2 and 1 is odd. 2 and 2, that's another even score. So we want the probability that the dart will hit a given region that's we want either 1 and 2 or 2 and 1. So let's look into that. How would we get 1 and then 2? Right? What's the chance of that happening? Well, we need to find the area of each of the regions. Right? We can see that for the small circle, in the small circle, the area of the small circle is small radius, little radius squared, 3 squared times pi. So that's 9 pi is the area of the small region. And then each of the parts of the small region are divided into 3, right? We've got 3 parts. So they each have a third of the area. That's 9 pi divided by 3. So they each have area 3 pi, right? Because it's a third of the whole thing. Okay, what about the large circle? We know the large circle has radius 6, right? So its area is 6 squared times pi. 6 times 6 times pi, that's 36 pi. Okay, but also we have to take away the part of the big circle that's actually like taken up by the little circle, right? So minus the little circle's area that's inside of the big circle. So 36 minus 9, that would be 27 pi. Okay, and then just like the little circle, the big circle is divided into 3 parts. 27 divided by 3, that is 9 pi for each part of the big circle. Okay, so now that we have each of the probabilities, right, this will be 9, 9, 9, and then 3 for each of the insides. What's the probability of odd first? Okay, well, we've got 2 big regions of 1 and 1 little region of 1, right? So that's 9 plus 9 plus 3, 2 bigs and 1 little. That makes 21. Okay, there's 21 pi out of a total of 36. 21 out of 36. Right, because the whole area, the entire area of this whole thing, we found out was 36 pi. And then after that, the chance of getting 2 is 1 big region and 2 little regions. So 3 plus 3 plus 9, That's 15 pi. It's 15 over 36. Okay, so the chance of getting a 1 and then a 2 is 21 over 36 times 15 over 36. Can we simplify? Yep, we can divide by 3, right? 21 divided by 3 is 7. 36 divided by 3 is 12. 15 divided by 3 is 5. Or another 12. So we get 30. Oh, that's 7 times 5 over 12 times 12. So that's a 35 in 144 chance of 1 and then 2. What about the chance of a 2 and then a 1? Well, that would be same thing, another 35 over 144. So we can add up those probabilities and we get a chance of 70 over 144 of getting an odd number. Can we simplify that? We can, right? Divide it both by 2. We get 35 over 72. All right. Candy sales of the Boosters Club for January through April are shown. What was the average sales per month? Well, okay, the first month we've got between 80 and 120, or one rung higher than 80. So we can see to travel 2 from 0 to 40, that's going to be 20. So every notch is increasing it by 20, right? We get 0, 20, 40, 60, 80. Another 20 is 100, right? So 100 in January, 40 plus 20, that's 60 in February, 40 in March, 120 in April. Adding that up, we get 320. We want the average, so we divide the sum by 4. That's 80 per month on average. 320 divided by 4 is 80. Okay. In 2005, we got a tycoon, invested $100 for 2 years. During her first year, her investment suffered a 15% loss, and then during the second year, showed a 20% gain. Over the 2-year period, what was the change in Tammy's investment? So let's see. We've got $100. And then we suffer a 15% loss, so we lose 15%. So what's 15% of 100? That's 15, right? So 100 minus 15. Now, after 1 year, Tammy has $85. Okay, during the second year, we get a 20% gain. So we get another 20%. Well, what's 20% of 85? That would be 85 times 0.2 for 20%. That's 17, right? So in the second year, Tammy gets another $17. So she starts with 85, gets another 17. 85 plus 17, that is 102. So in the end, she went from $100 to $102. So how much did that change? Well, we went up 2. That's 2%. Tammy gained 2%. Okay. We've got the average age of the 6 people in room A is 40. 4 people in room B is 25. What would the average age be if everybody was combined? Well, there's 6 people in room A. So that means that if they average 40, they have to add up to 40 times 6, that's 240. So everybody, no matter how old they are, their ages in room A add up to 240. In room B, average age is 25. So the 4 people in room B, they add up to their ages, add up to 25 times 4, that's 100. Okay, so we've got 240 plus 100. So if they were combined, everybody's ages would add up to 340. Okay, and now that's 6 people plus 4 people. So now there's 10 people whose ages add up to 340. So how do we find the average? We have their sum, the sum of their ages, which is 340, divided by the number of people, which is 10. So 340 divided by 10, that's 34. Answer choice D. Okay, 39 students in 8th grade at Lincoln Middle School. 1 dog or 1 cat or both a dog and a cat. 20 students have a dog, 26 have a cat. How many students have both a dog and a cat? All right, so let's draw this out. Make a Venn diagram. That's what this shape is called. So we have people with dogs, people with cats, and remember this inner thing is people with both dog and cat. So if we say there's 20 students who have a dog, that's everybody in here in this big circle. So that includes the people who have only a dog and the people who have both a dog and a cat. So that's 20 students have either just a dog or a dog and a cat. Okay, and then we have 26 students who have either just a cat or both a cat and a dog. So that's another 26. But notice, we've double counted. We counted this middle area 2 times. Once for the people with the dog and once for the people with a cat. Because they have both, they're counted twice. So when we add up 20 plus 26, we get 46, even though there's only 39 people in the class. So what we've got is dog plus cat plus dog and cat plus another dog and cat is 46. But the total number of people in the class, that just accounts for the people who have a dog, the people who have a cat, and the people who have both. Right? We only count them once. To count the number of people in the class, that's 39. Okay? So this is from the double count. So if we subtract this, if we do the top equation minus the bottom equation, we would get dog minus dog, so no dog, cat minus cat, dog cat minus dog cat, and then we're left with a dog cat. The people who have both a dog and a cat equals 46 minus 39. That's 7 people have both a dog and a cat. Ball is dropped from 3 meters. First bounce, it rises to a height of 2. So this is 2. This is 3. Okay, 2/3 of its height of the previous bounce. On what bounce will it first not rise to a height of 0.5 meters, so half a meter? So that would be about here. When does it first not do that? Okay, so we went from 3, we went 2/3, so times 2/3, and then we got to 2. That was the next height. So 3 and then 2. So we keep multiplying by 2/3. So times 2/3. Now we get to 4/3. That's the next height. So 4/3, that's bigger than half, right? 4/3 is more than 1/2 because 4/3 is bigger than 1. So it's definitely bigger than 1/2. Okay, on the next bounce, after 4/3, it bounces to the height, 4/3 times 2/3, to 8/9. Right, now it's less than 1 meter, but it's still more than half, right? Half would be 4.5/9. So we're still bigger. Got another 2/3. Now we're at 16/27. Is that bigger than a half? Well, half of 27, that's 13.5. So we're still bigger. So 16/27 times another 2/3. That's 32/81. Okay, now are we less than a half? Well, 32 times 2, right, doubling 32 is 64. So if we double the 32, we're still not at the whole thing. So now we're less than a half. 32/81 is less than a half. How many bounces did that take us? Took us 1 bounce, 2 bounces, 3, 4, 5 bounces. Answer choice C. Okay, Dr. Harmon needs to know the combined weight in pounds of 3 boxes he wants to mail. However, the only available scale is not accurate for weights less than 100 pounds or more than 150 pounds. It's a very specific scale. So boxes are weighed in pairs in every possible way. The results are 122, 125, and 127. What is the combined weight in pounds of the 3 boxes? Okay, so we know that the 2 lightest boxes are going to weigh the lightest amount put together, right? So let's say we have boxes A, B, and C, where A weighs less than B and B weighs less than C. So the lightest boxes, A and B, are going to combine for the lightest weight. That's 122. Okay, now our lightest and our heaviest, that's going to be the next one. A plus C is 125. And lastly, our two heaviest boxes will weigh the heaviest amount. B plus C is 127. Okay, now we want the combined weight of the three boxes. Well, what if we added everything up? We added up these three equations. A plus B plus A plus C plus B plus C. That equals 122 plus 125 plus 127. Okay, what do we get if we simplify that? Well, we have two A's, right? Oh, remember we have two A's and two B's and two C's. And then we were adding 122 plus 125 plus 127. That adds up to 374. So 2 times A plus B plus C is 374. We just want 1 time A plus B plus C. Right? So we can divide by 2. 374 divided by 2. What do we get? $187. That's answer choice C. Okay? 3 A's, 3 B's, 3 C's, placed in the 9 spaces so that each row and column contain one of each letter. A is placed in the upper left. How many arrangements are possible? Okay, so now that we've got an A in this, let's look at our first row, so this line. Well, we still need to put a B and a C, right? There's 2 ways to do it. We can either go B and then C or C and then B. So there's 2 ways to put those 2 letters. Let's say we go with B and then C. Now we've got our third row. There's 2 places to put the A, right? The A can either go in this second spot or this third spot. Let's see. Let's say we put it in the second spot because it doesn't really matter. That's 2 more places. Now our spots for the B and the C are set, right? The C can't go here, right? Because the C is already in this column. So C has to go here and the B has to go here. And now the third row is set, right? A has to go here, C has to go here, B has to go here. So there's 2 choices we made. We chose between either B or C and B in the first row, and then we chose where the A goes in the second row. So we made 2 times 2 choices, so 4 ways to arrange this grid. In Teresa's first 8 basketball games, she scored 7-4, 3-6, 8-3, 1, and 5 points. In her 9th game, she scored fewer than 10 points, and her points per game average for the 9 games was an integer. Similarly, in her 10th game, she scored fewer than 10 points, and her points per game average for the 10 games was also an integer. What was the product of the number of points she scored in the 9th and 10th games? Alright, so let's look at her total score after her first 8 games, right? We know she scored the 7, 4, 3, 6, 8, 3, 1, and 5. That's a lot. So let's do some addition. 7 and 4 would make 11. 3 plus 6 is 9. 8 plus 3 is another 11. 1 plus 5 is 6. So adding up those points, we get 20 plus 11, that's 31, plus 6 is 37 points. Okay, she scored 37 points. Okay, then in her 9th game, she scores some number of points. So 37 plus, we'll say P for the number of points she got in the 9th game, divided by 9 has to be an integer. 37 plus some number of points divided by 9. So what does the number of points have to be for 37 plus that number to be divisible by 9? Right? Because if she scored 0 points, we've got 37 over 9, and that is not divisible by 9. Well, the next multiple of 9 after 37, right, we want to get to a multiple of 9. So the next multiple of 9 after 37 is 45. Right, 45 is 5 times 9. So we want to get to 45. We're at 37. We'll do some subtraction. So we get that the number of points is 8, right? 37 plus 8 is 45. Okay, so in the 9th game, she scores 8 points, not 45, although that'd be impressive. So P for the 9th game, that is 8 points. Okay. Then what about the 10th game? So after the 9th game, she's at 45 total points, right? Now we want some new number, we'll say n, so that 45 plus n divided by 10 is an integer, right? Her average for the first 10 games was also an integer. So 45 plus n divided by 10. What's the next multiple of 10 after 45? Well, we know 5 times 10 is 50, so our next multiple of 10 after 45 is going to be 50, right? So we'll do 50 minus 45. That is 5. So n is going to be 5 points, right? 45 plus 5, we get 50 divided by 10 is an integer. So 9th game, she scored 8 points. 10th game, she scored 5 points. And we want the product of those 2 points. And remember, product is multiplication. So we want to multiply those 2 points together. 8 times 5, that's 40. Answer choice B. Students guess that Norb's age is 24, 28, 30, 32, 36, 38, 41, and a lot of other things. Norb says, at least half of you guessed too low, 2 of you are off by 1, and my age is a prime number. So, let's look at this. So we've got all of these numbers. How many guesses do we have? Let's count that out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 guesses. So half of you guessed too low. So let's look at the bottom half. They're all too low. That'd be these 5, right? 5 is our bottom half of 10. They guessed too low. So Norb has to be older than 36. So we'll eliminate choices A and B. Okay. We also know 2 of them are off by 1, and the age is a prime number. Okay. So if his age is a prime number, he can't be 48, right? That's not prime. So now it's between 37 and 43. Okay. So now we have either age 37 or age 43. So which one of those numbers is off by 1? So has 2 that are off by 1, right? We need 2 guesses that are just 1 away from his true age. So let's look at 43. We've got somebody guessing that he was 44, but nobody guessed that he was 42, right? So that means no 2 people are off by 1 on that age. So that's not the right answer. What about 37? Here we see that's where 37 would go in the order. One person thought he was 36. One person thought he was 38. So in total, we've got 2 people who are off by 1, right? 36 is 1 less. 38 is 1 more. So that is our answer. Answer C.